Today, let us look at a sphere. You must have come across spheres all around you. A well-rounded ball or a marble is a sphere. A sphere is a ball whose surface area and volume can be found using integral calculus. If we stack up circles of different radii, we would get the volume of a sphere by adding up the areas of all these circles, which would be 4 upon 3 times pi r cube. Now, instead of circles, if we were to stack rings of different radii conforming to the shape of the sphere, then we would find the surface area of the sphere, which would be the sum of perimeters of all these rings, or 4 pi r square. So the lateral or total surface area of a sphere is the same and is equal to 4 pi r square. If we cut a sphere into two halves, we get a hemisphere. The volume of a hemisphere is half of the volume of a sphere, and the lateral surface area is half of the lateral surface area of a sphere. Substituting the values, we get the volume of a hemisphere as 2 upon 3 times pi r cube and the lateral surface area of a hemisphere as 2 pi r square. However, the total surface area of a hemisphere is slightly different because there is a base. So the lateral surface area, which is 2 pi r square, plus the base, which is a circle, or pi r square. So the total surface area comes out as 3 pi r square. Let us look at a problem. The diameter of a metallic ball is 7 centimeters. What is the mass of the ball if the density of the metal is 9 grams per cubic centimeter? It's a metallic ball, hence a sphere. The diameter is given as 7 centimeters. Hence, the radius would be half of the diameter, which is 7 by 2 centimeters. Now we have to find the mass of the ball. Since we are given the density, we would need to multiply it with volume. So let us find the volume first. It would be 4 upon 3 times pi r cube. Let us substitute the values and simplify. Let us leave the volume like this. Now, in order to find the mass of this ball, we would need to multiply the density by volume. Let us substitute the values and simplify. We get 3 times 11 times 7 times 7. Let us club them into pairs. Let us take 3 and 11 together and the 7s together. We get a 33 times 49, which gives us 1617 grams. Let us look at another problem. A dome of a building is in the form of a hemisphere. From inside, it was whitewashed at the cost of 4,989 rupees and 60 paise. If the cost of whitewashing is 20 rupees per square meter, find the inside surface area of the dome and the volume of the air inside the dome. So we have a hemisphere. We do not know the radius, but we know that it was whitewashed from the inside. So we are only talking about the lateral surface area of this hemisphere. Now the cost of whitewashing is equal to rate times the lateral surface area. Let us substitute the values and find out the surface area. Now surface area can also be written as 2 pi r square. Let us equate that to the surface area we just found. Let us substitute the value for pi and cross multiply. Upon simplification, we find that r square is equal to 5.67 times 7. If we were to remove the decimals in the numerator, we would have to write as many tens in the denominator. Since there are 2 places in the decimals, we shall write 100 in the denominator. Let us prime factorize 567 and put them in pairs. So we get 2 pairs of 3's and a pair of 7 in the numerator. We also have a pair of 10 in the denominator. Now finding out the square root on both the sides, we get r is equal to 3 times 3 times 7 divided by 10. Or the radius is 6.3 meters. Now the question is asking us to find the volume of air inside this dome. Now that would be equal to the volume of this hemisphere, or 2 upon 3 pi r cube. Let us substitute the values and simplify. Upon multiplication, we find that the volume of air is 523.9 cubic meters. Let us look at another problem. 27 solid iron spheres, each of radius r and surface area s, are melted to form a sphere with surface area s dash. Find the ratio of s and s dash. So we have 27 iron spheres. And we are melting it to form one big sphere. Alright, let us call the radius of the small sphere as small r and radius of the bigger sphere as capital R. Now since the volume of the small spheres was melted to form the volume of the bigger sphere, mathematically we could write that 27 times volume of small sphere is equal to volume of big sphere. Or 27 times 4 upon 3 pi small r cube is equal to 4 upon 3 times pi capital R cube. Let us divide both sides by 4 upon 3 pi. We get 27 small r cube is equal to capital R cube. Now 27 is also the cube of 3. So 3 small r whole cube is equal to capital R cube. Taking cube root on both sides, we get 3 times small r is equal to capital R. Now we have to find the ratio of s and s dash. Now S is surface area of small sphere and S dash is surface area of big sphere. The surface area of small sphere can be written as 4 pi small r square. And the surface area of big sphere can be written as 4 pi capital R square. We can simplify 4 pi in the numerator and denominator. Now let us substitute the value of capital R in terms of small r. So we get r square divided by 3r whole square, which is equal to 1 by 9. So s is to s dash is equal to 1 is to 9. Recall that we had to find the ratio of s and s dash. Let us recap the volume and lateral surface area of a sphere. In the next lesson, we shall look at the surface area and volume of a pyramid.